Hey guys, okay, we're going to start out today. We are on Q18 on Tuesday. So, starting right out today, man, they started with a bear of a problem. So this one, we're doing order of operations, obviously. But we have our bracket friends, and that complicates things just a little bit. So, let's go through this real quick together. I'm going to get my PEMDAS letters up here just to help me stay organized. And remember, this bracket situation kind of falls in here, but really, well, let's just do it and we'll see how it goes, okay? So within the bracket, we have a parenthesis. So we're going to take care of that first, okay? 20 plus 7 obviously is going to give us 27. And that takes care of the parentheses. Since there is not anything between the 3 and the parentheses, hopefully we remember that means we're going to multiply, okay, or times. So then I'm going to pull everything else down, 2.5 plus 3, and put this back in those brackets just so we can kind of still see that. Now that we're to this point, we're going to work within the brackets kind of like they're a parentheses, but we're going to go in the order of PEMDAS. So there aren't any exponents, but there is multiplication or division. There's a multiplication that we have to take care of, okay? So 3 times 27. 27 times 3, let's do that right over here. 7 times 3 is 21. 3 times 2 plus 2 is going to give us 8. So this portion is going to be 81. We pull everything down, 2.5 plus 81, still inside the brackets with the 4 out here. Now, if I add 2.5 to 81, I'm going to end up with 83.5, right? Now, that takes care of everything happening in those brackets. And since, once again, there's no mathematical symbol here, we're going to be multiplying. So we're going to have 4 times 83.5. Let's go over here in some blank space. We'll work this out. Times 5. Okay. 4 times 5 is 20. 4 times 3 is 12, plus 2 more is 14. 8 times 4 is 32, plus 1 more is 33. And I have this decimal here. It's 1 scoop in. So I just have to make sure I scoop in here. And remember, if there are zeros on the end in decimal land, they don't carry any value, right? So we really could say that our answer for this one is 334. Okay. All right, good job. That was a tricky one. Okay. This one, we're just going to find the quotient, dividing with fractions. Keep change flip. We're going to keep the 4/15. We're going to change that division symbol to a multiplication. We're going to flip 1/6 to become 6 over 1. Okay, then we're just going to multiply across. 4 times 6 is 24. 15 times 1 is 15. And I'm not going to leave this like an improper fraction. So let's think about how many 15s we could fit into 24. Well, it could fit 1 in there, and I would have 9 left over. Let me just do that here so you can see in case we're a little confused. So if I do 1, and I work out the subtraction down here, I'm going to be left with 9 15ths. Now, I could leave it there, but we like to simplify as much as we can, right? And I know that 9 and 15 are both multiples of 3. So if I if I divide 9 by 3, I'm going to get 3. And if I divide 15 by 3, I'm going to get 5. Pull our 1 whole down. So our final answer is 1 3/5. Okay. All right. Our friend Tamara makes $42,786 a year, and we want to find out how much she makes each month. We know that there are 12 months in a year, so we are going to divide 12 into this 42,786, and let's see how much she makes every month, okay? 12 goes into 42 3 times. 36. Through that subtraction, 12 minus 6 leaves me with 6. Okay, pull down the 7 next. 12 goes into 67 5 times. 7 left over. Okay. 78, it goes 6 times. That's going to give me 72 with 6 left over. Pull down that 6. Once again, 5 times. 5 times 12 is 60. Subtract here. Let's put a decimal there because we're not quite done, and a 0. Ooh, this is looking good. So I'm going to also bring that decimal up so I don't forget about it. 12 goes into 60 5 times. I think we're going to be done. Yes. Okay. So per month, Tamara makes $3,565.50. When we're talking about money, we usually put at least to the hundredths place because that's how our pennies work, right? All right. Okay, finding the products here. So let's take 584.8. We're going to multiply that by, and remember with multiplication, we don't necessarily have to line up those decimals. Okay, so we're going to just do 0.73 and line it up with the numbers instead. Okay, so let's have 3 talk to everybody at the party. 3 times 8, 24. 3 times 4 is 12, plus 2 more is 14. Again, 3 times 8 is 24, plus 1 more is 25. 3 times 5 is 15, and 2 more would give me 17. And 3 is done chatting. So let's save a spot for him on the couch. 7 times 8, that's going to give us 56. Carry the 5. 7 times 4 is 28, and 28 plus 5 is 33. 7 times 8, once again, is 56, plus 3 more is 59. Carry the 5. 7 times 5 is 35, plus 5 more is 40. And 7 is done talking to the party. Now, you can make the choice. When we have a 0 down here, it's just, we know it's going to be just a row of zeros. And it shouldn't affect the total. Let me just show you. So we need to save a spot for 3, and we need to save a spot for 7, and now we would start multiplying, right? But 0 times anything, of course, is 0. So 0 times 8 is 0, 0 times 4 is 0, 0 times 8 is 0, 0 times 5 is 0. So you can see that's not going to affect any of the addition we do. 0 doesn't have any value here. Okay, 4 plus 0 plus 0 is 4. 4 plus 6 is 10, so keep the 0, carry the 1. 5 plus 1 is 6, plus 3 more is 9. 7 plus 9 is 16, keep the 6, carry the 1. 1 plus 1 is 2, and 4 plus 0 is 4. Now, let's remember we had several decimals, well, 2, I guess. So we need to talk about how many scoops we need to take care of. So 1, 2 to get to that one, and one more to get to that one for a total of 3 scoops that we needed to do. So we need to scoop in 3 here, right? So final answer, 426.904. Okay, using the distributive property here, we want to think about what we could pull out of both of these. What factors do they share? And they actually both share 15. So if I took 15 times 2, I would get it back up to 30, right? And if I took 15 times 5, that would get me back up to 75. So 15 is going to be what we pull to the outside, and in the parentheses we would have 2 plus 5. And that would take care of our distributive property. Okay. Shannon scored 36 points on 6 questions on her test. What is the unit rate for 1 question? So if she has a total of 6 questions, she got 36 points. We are just simply dividing 36 by 6. And we know that's going to go 6 times, okay? So the unit rate is 6 points for every 1 question. Okay, or we really could just say 6, because 6, or any number over 1, is just that number. Okay. All right, man, these ratio tables, you guys can do way harder ratio tables, so this shouldn't be hard. Adults, they're counting by 2s, and children, it looks like they're counting by 1s, so easy peasy lemon squeezy. Should fill that in with 3 and 4. Okay, this one's a good challenge problem. So Katie's selling lemonade for $1.50 per cup. She decides to put her cups of lemonade on sale for 90 cents. So we want to figure out what discount is she giving when she has her 90-cent sale, okay? So if we just to collect our information, keep it organized, 100%, or the original price, was $1.50. Okay. And then she ended up lowering that down to 90 cents. So we need to find what percent was the discount. So we're looking for this guy, right? So let's see if we can figure out what this was that gave us the 90 cents. Then we'll subtract that percentage from 100 to find this, okay? So currently I have 150 over 100, and then some percentage here, and 90 cents. Okay, don't let those decimals throw you. Just keep in mind we're dealing with money, but it shouldn't be too frightening for you, okay? So as always, I want to reduce these. These are not friendly numbers, right? So, but I want to think about something that, how could I get over to 90? So if I reduce, because all of these end in a 0, I could think about tens, dividing everything by 10. But also if they all end in a 0, I know they're all multiples of 5. So I think, just as I'm kind of thinking through this, that might be a little bit more comfortable. So if I divided 100 by 5, I'd be left with 20. And if I divided 150 by 5, I'd be left with 30. Right? Now, it's a whole lot more comfortable to see what we would need to do to get 30 to 90. Well, we would just have times by 3. So we'll do the same thing to the bottom. 20 times 3 would give us 60%. Now remember, the 60% is what she paid, or what her customers were going to pay with the sale, right? 60% is this portion. So if my goal is to get to 100%, what would I need to get from 60 to 100? Well, I would need 40 more percent. So percent of her discount is 40%. That's a good example of why drawing it out or talking through it really can help with the math that you're trying to solve. Makes a big difference sometimes. Okay, how many feet are in 84 inches? And they gave us the information that there's one, for every 1 foot, there's 12 inches. Okay, so what we essentially just need to do is figure out how we could get from 12 to 84. And I happen to know that if I multiply 12 times 7, that gets me to 84. If I didn't know that though, I could just divide and kind of work that out and see what number I need to get there. But hopefully we mostly know our 12s times tables, or we can kind of work that out. 1 times 7 then would be 7. So in 84 inches, there are 7 feet. Okay, have a great day.